Hi, for this today YouTube video, I'm going to explain about Kafka architecture. Apache Kafka is one of the messaging softwares in the market nowadays. So most of the companies they are preferring to use the Apache Kafka. If anybody wants to build any event-driven architecture, if they want to build any notification system, alerting kind of system, Kafka would be very useful. Also, the Kafka is majorly used to migrate data from one data source to another data source using event-driven architecture. If you take banking applications or finance applications, because using Kafka, you can transfer huge volumes of data, and transfer rate also very high comparing to RabbitMQ and other event-driven softwares. So I want to explain how Kafka works and what is the high-level architecture of the Kafka. You can see here. Initially, in Kafka, we need to configure the topic, and each topic can be partitions with multiple partitions. So in each partitions, we can actually send events using a producer, and whatever the consumer is going to subscribe the particular topic and specific partition, they will consume the data. So you can see here there are three producers. They are going to produce they are going to use separate topics, and each topic is having a partition. So we can actually send events in different partitions. We can also specify we can also give the name for partitions. That way the consumer, so whatever the consumer is specifically subscribed to a particular topic and using and specific to, we can actually provide the qualified name of the partition also when we provide the topic name, and the consumer will actually consume the events from particular partition of the topic. So the thing is, it is very fast. You see, for tracking the failed messages, we can use dead letter mechanism, dead letter queue concept, where all the failed messages will be routed to the dead letter queue, and where we configure the persistence data source for failed messages. We can also store them in a particular persistent data source also for future reference. Dead letter queue, it's a kind of temporary. It will store all the failed messages there for some period duration. We need to specify the expire date and the duration, how long the failed message can stay there. So you can see that is not there in this image, but the thing is, that's how the Kafka works. The Kafka, you can actually configure the cluster using multiple topics. You can create multiple brokers, run multiple topics, multiple nodes are there. You can create it. You can actually there will be zookeeper which will handle all this cluster. That is not there in this diagram. So you can see it is Kafka is very good example for processing millions of events per second. It is very fast. So if we take RabbitMQ is mostly rule based. So we will actually configure the queues, number of queues, and different queues, like depending on the architectures, like whether it is a fan out architecture or whether it is a single queue or a topic related. There are different types of configurations are there in RabbitMQ, but it is more of a rule based. You see, whenever we want to process specific messages based on the rule, then we will use that. The Kafka is a very good example here. Most of the companies, they are still preferring it. I worked in one of the projects, banking projects. So what we did is, there we actually tried to migrate the Oracle data into Cassandra database. So the Oracle database data is the latest data. It is transactional data, the customer data. For every day or every second, we will receive a couple of records into our database, and based on the event, whenever the data is inserted into the Oracle database, and we actually have written some producers, they actually read the event, and they'll actually publish those records into another topic. So we can actually multiple consumers followed by the producers, or you can actually read the events, database events using query or webhooks or REST API. You see, then we actually read the latest data, updated data, and the producer will update that, publish that, push that record into the topic, Kafka topic. And other side we'll have the consumers written using a Spring Boot technology. They'll read the data, and they'll update that event into the Cassandra database. That way, both the Oracle and Cassandra database, both database will be in sync in real time. So we will not miss the real time data. So why we migrated the data to Cassandra DB? Because Oracle database is a transactional database, for analytical purpose we cannot directly use it, because already the production queries are running in Oracle database, so it may impact the existing Oracle database. It is application specific database, right? So we cannot use it for analytical purpose. So that is why we want to pump this data to another database, Cassandra database. It is a key value type of column oriented structure. It follows the data model, and once we actually publish the data there, we can actually visualize all the statistics, analytics. We can see that there, and we can actually use the Cassandra database. It would be very faster, right? That way, so we'll be able to migrate the data. So we observe the Kafka, the data transfer rate is very fast. So you can actually pump, huge volumes of data. You take any other asynchronous messaging software, they are not very fast comparing to Kafka. But Kafka is very fast. It is specifically designed to transfer high volumes of data per second. And also you can configure this the failover mechanism. Whenever something is failed, some message is failed, you can actually store the failed messages into another data storage for future purpose. And the purging mechanism is there. You can configure it. There are many features are there with the Kafka. You can actually use it along with the Spring Boot. You see, that's how we use the Kafka for one of the use cases I explained you. So for migrating the data, that is the best suitable example, because you see, why do we want to use asynchronous message when we have a Java AMPQ messaging systems, or RabbitMQ is also there. The main thing is the data transfer. Huge volumes of data can be transferred using Kafka. So millions of records, millions of events will be processed per second. You see, that is where the Kafka will come into the picture. So whenever you want to use a Kafka, this is the best use case. You want to transfer multiple records, or you want to process multiple volumes of data using asynchronous software, then the Kafka will come into the picture. I hope you understand this. This video will be useful for you. Thank you.